Hi, today we are going to talk about the forward rate agreement, or FRA in short. This is essentially a forward, but the only difference with any other forwards is that the agreement here is based on the interest rate rather than, say, tangible equity or bond or FX. So this is a forward on interest rate. Sometimes it can be confusing when people say when we buy a FRA or we sell a FRA. So just think about it as when you buy a FRA, you're actually buying LIBOR and you're paying a fixed rate that you agree up front. And when you're selling or short the FRA, you're actually selling the LIBOR and you are receiving the fixed interest rate. So maybe let's start with some notation. Normally when people say buy a FRA, they'll indicate the maturity and the tenor of the LIBOR. So when people say, let's say for example, when there's a 3/9 FRA, okay, say notional, we need say notional is 1 million, we need something to base the interest rate upon, so I have to calculate the interest rate payment or receipt. Let's say the fixed rate that we agree up front, K, is 4%. Okay, so let me draw a timeline, which most people do to notate the FRA agreement. So we are at t equals 0. The 3 here means that refers to the maturity of the FRA. So this is the maturity, and this is also the date which the LIBOR is being monitored. Okay, so we'll at this date we'll take a look at the LIBOR here and decide whether the agreement is profitable or is it a losing trade. And the LIBOR here that we should look at is the 6 months LIBOR. Why? Because we have this, but this date here, this duration here, which we says 9, so it's 9 months from t equals 0, okay, which is also equivalent to 6 months from the maturity of the FRA. So basically what it's saying is, as at the 3rd month, when the FRA matures, we should look at the 6 months LIBOR, okay, on this date, assume that, say, this is 5%, and then determine what's going to happen as at the 9th month. Okay, so as at the 9th month, we are going to calculate 2 numbers, the fixed rate and the floating rate. Okay, so assume that we are buying this FRA. Okay, so this is a buy trade, and I've mentioned that when you buy a FRA, we are buying LIBOR. Okay, so when we buy LIBOR, we are receiving the float side. So this is a receive, and then we are paying the fixed side. Okay, calculation of the fixed and float is quite straightforward. The fixed rate is basically given by, I've said that fixed rate is 4%, so it's 4% over, because this is, we are basically talking about 6 months, right? So it's half a year by 2. So effectively, over 6 months, you are paying 2% multiplied by the 1 million. Okay, so for the float side, it's also simple. We know it's 5% over half a year times 1 million. Okay, so I can write in notation form the formula here. Basically, LIBOR denoted by L multiplied by time, okay, which is 0.5, which is 6 months, and the notional. And similarly for here, let's denote the fixed rate by K, okay, and time, and the notional, okay. So all in all, for this trade, we have made a profit of 5,000, okay, which is basically because they're receiving this amount and then paying this amount, and this amount is more than this amount, so making 5,000, which will be paid as at T equal to 9 months. Okay, so you can cut short these two formulas by writing the profit as notional times time into LIBOR minus fixed rate. Okay, so this is basically the payoff that we expect at the end of 9 months, once we know the LIBOR as at the third month. Sorry. So let's move on to the valuation of the FRA trade. Okay, just now at this point I was referring to the payoff of the FRA trade, which is given by this formula. Let's look at the valuation. We can value this FRA trade by replicating the fixed and floating legs separately. Let's start with replicating the fixed leg. What does replication mean? Replication means that you can do this exact same trade by using different vanilla products like bonds or equities. In this case, I will use zero coupon bonds to replicate this entire FRA trade. I'll do the fixed rate one first. Okay, so the idea is we want to obtain this amount by doing certain trades today using zero coupon bonds, which is zero coupon bonds are basically bonds that doesn't pay coupon and always sold at a discount, so that the pricing is very straightforward, it's very liquid, and it's easily observable. Okay, let's have the another diagram where I put in the values in notational form rather than numbers. So time, let's say this is time A, time B, okay. So this is basically the time lapse for LIBOR is basically B minus A. All these are notation in years. So let's say if A is 3 months, this is 3/12. B is say 9 months, so this is 9/12, and then this is half. B minus A, T is equal to half. Okay. So we want to, for the fixed leg, we want to obtain this value. Okay. As when it matures as a T equal to 9 months, T equal to B months, and let's also make another assumption. We assume that the notional is 1. Okay, L equal to 1. Notional is not really an issue here. We assume equal to 1 because when you obtain the final valuation of the FRA, we simply multiply by whatever notional that you want. Okay, so we want to obtain this amount. We can replicate this fixed amount by selling a zero coupon bond. I call it zero coupon bond, ZCB. Selling zero coupon bond of notional T times K. Okay, so assume that the price of the bond is currently PB. Okay, so when we sell the bond now, we'll be receiving an amount equal to PB times T times K. Okay, so when it reaches maturity at time equal to b, this PB becomes 1 because the zero coupon bond at maturity will be getting back $1. So at maturity we'll be ending up with T times K, okay, which is basically T times K for the fixed rate. Okay, so this is the amount that we'll be receiving when we sell this zero coupon bond. Okay, let's try to replicate the floating rate. Okay, we need to do two things for the floating rate. As said, so we can replicate. Okay, the idea is to try to obtain L times T at the end of the 9th month. Okay, so let's see how we can do that. We can replicate this by buy 1 unit of zero coupon bond. Okay, matures at A at this point. Okay, the current price, let me denote it as P to the power of A. Okay, we can sell 1 unit zero coupon bond maturing at T equal to B, price PB. Let me denote it as PB. Okay, so why do we do that? Let's imagine that the first zero coupon bond matures at T equal A here. What happens at this point? We'll be receiving $1. Okay, so as I here we'll be receiving $1. So we can invest this $1 into say we can deposit in the bank or something, and then we can earn LIBOR over the period of T. Okay, so by earning LIBOR over a period of T, when we for the second bond, when it matures as at B, okay, the LIBOR leaks will knock off and we end up with the principal amount will knock off and you end up with L times T, okay, which is the equivalent of this one, which is what we are trying to drive at. Maybe let me write down in what happens after first year. Okay, so when T equal A, this first zero coupon bond will give us $1. Okay, so now we have $1. We invest this $1 in LIBOR. So when T equals B, this $1 will become 1 plus LIBOR into $1, right? Okay, so for the second zero coupon bond, this will be maturing as at B. Okay, as at B, and we can use this $1 to knock off against this $1 for the second zero coupon bond, which means that this whole amount, what remains is basically L times T. Okay, I missed out T here. Okay, so this is L times T, which is exactly what we are trying to get at for the floating leg of the FRA. L times T, we said we're going to set N as 1. Okay, so basically what this means is by doing this replication we can get the same payoff as the floating leg of the FRA. Okay, so the net amount that is required under this floating leg portfolio is It's basically PA minus PB. Okay, so now it becomes clear we have a valuation for the fixed leg of the FRA, and then we have a valuation for the fixed floating leg of the FRA, and the net value of the FRA is simply a difference between these two, which I will write down here. Okay, the net value is simply the floating leg PA minus PB, okay, minus the fixed leg PB times T times K. Okay, we can simplify this by moving PB out. Okay, so this is basically the value of a FRA as at any point in time before it matures. I think the value of zero coupon bond may not be familiar with some people. So some people are more familiar with having interest rate rather than having this amount shown as a value of a zero coupon bond. So we can easily convert this into a interest rate format, which is PA is simply equal to 1 over, let's say RA is the rate for this period. Okay, so this is simply 1 over RA, expressed in annual terms, so we have to multiply by A. Okay, so assume that this is 3 months, so this is R multiplied by 3 over 12. Okay, so similarly for B, we can express this as 1 over 1 plus RB multiplied by B. Okay, so this one, if you put these values inside, it should become a more familiar formula.